Okay. All right, I've started recording. So let's discuss the homework from last week. Let me bring it up. Homework 2. Okay. Hope you guys attempted it, right? Avinash, Vihan, Kunsh. Okay, I don't know where others are. I mean, a couple of people are out. They messaged me, but others should be joining, hopefully. But we'll get started. Recording is on, right? Yeah. Okay, so the question 1, isosceles triangle PQ and PR.
So you aren't sharing your screen.
Oh, sorry. Yeah, now I am. Okay. Avinash, did he do this one? What did he get?
So this is the question I didn't understand in this.
What was difficult about understanding this one?
Wait, I think I got an answer, but I don't know if that's correct.
That's fine. Yeah, as
Yeah.
long as you got something, why don't you call
I
out
got
what-
64 pi.
64 pi? Okay.
I think that's wrong.
Okay.
I don't know if mine is correct, but I got 60 by 21 pi.
60 by 21 like this.
Yeah.
Okay.
Pi.
All right.
I'm pretty sure it's wrong, but I think.
Okay, that's fine. Let's
I got an answer, so as well.
Go ahead, Apurva.
So I got 225 by 64 pi.
224 by 64 pi. Okay, so we have a few answers. Let's discuss. Shivank, are you able to turn on the video, please? Okay.
Yeah,
So
sure.
So let's draw a diagram, each measuring 17 centimeters. So let's say 17, 70, and the altitude is 8. So I drew it a little flatter, seeing the altitude is small. So let's say this is PQ and PR are the adjacent sides, right? Or the equal
So
sides.
I got 225 by 16 pi.
225 by 16 pi. Okay.
Yeah.
So Apurva said 225 by 64. You said by 16. Okay. All right. Let's check. Now, this is the altitude. The altitude is 8. Okay. I've constructed such that we have a triplet. So this is 8 and this is 17. You know by now that 8, 15, 17 is a triplet. So this is 15, 15. And we are talking about a circle which is inside this, right? So this is the circle, which let's say the incenter is somewhere here. It'll touch all of these 3. So this is the incircle. So it'll have a certain radius. So just visually, I can see the altitude is 8. Roughly around half of that is the radius. So approximately radius is around 4, right? Did someone say something or is it just noise? Right? So approximately radius is 4, which means I expect an answer. I mean, just visually, I'm doing very, very visually here, right? Obviously, it's less than 4 because the entire height itself is 8. So the incenter, so this, and this are the radius, right? It should be less than 8, less than 4, in fact. It looks less than half of it. Okay, so even assuming it's 4, it should be 4 pi times 4 square, which is 16. So clearly this is wrong, right? I'm just helping you guys how to eliminate your own answers. Everyone will do silly mistakes, but you should be able to catch your mistakes. That's important. Okay, so this is still very much in the game because it's 3 times pi. Although this looks little on the smaller side, right? Because this would mean the radius is something like, I don't know, 1.7 or something, right? So I'm saying the radius is around 4. So this is pi times 4 square is what I'm expecting. So this is how much? This is again, this quantity is less than 4, right? 64 times 4 is 256. So this is more like pi times maybe 2 square. So this quantity is, yeah, this is close to 15 or so, right? 15 square is 225. So approximately this is close to, right? So if I have to take a random guess, if I have absolutely no idea how to do this problem, I would go with this, right? Not to say that this is right, but there's something fishy about all of these other answers, right? These are these answers. This is like pi times 8 square, which is right off. You understand how to eliminate answers without knowing too much. Okay, suppose I forgot the formula for incircle radius, kuch bhi ho, you should still be able to intelligently eliminate a few answers. Now, what is the radius of the incenter? Delta by S, right? Delta is what the area is, half into base into height. upon the semi-perimeter. Semi-perimeter is how much? 30 plus 17 plus 17, 64 by 2, which is 32. So ultimately, what is this? 4, 8, 2, sorry, 4, 15 by 4. See, it's approximately 4, 15 by 4. So my guess was right that the radius is approximately 4, slightly less than 4, just by visually, I'm not saying you should draw a perfect diagram or something, but a rough diagram itself will call out some wrong answers, very obvious wrong answers. So therefore the answer is, this is right. So pi times r square, 25 by 16. Punch, that was you, right?
Yes, sir.
Okay, good job. Did the others find your mistake? Apurva, you are close. You got the
So,
225. What was your
yeah.
mistake?
So when I was calculating the area, what I did was instead of doing 120 by like the area, getting the area as 120, I got it as 60. So I did 1 by 4 into base into height by mistake instead of half
Oh.
base into height.
Okay. The other common mistake people will do in the semi-perimeter, they'll forget to divide by 2. They'll just do 15 plus 15 plus 17, 34, whatever, 64. Instead of dividing by 2. Semi-perimeter, divide by 2, obviously, right? So that's a very common mistake I do. But 1/4 base into height is, I'm hearing after a long time, Apurva. That's the record. I'm just teasing you, but yeah, all sorts of mistakes are possible. I've done my own share. I continue to do as well. But again, point is, you should be able to catch your mistakes. Everyone does mistakes. You should be able to catch your own mistakes by doing some basic, simple sense checks like this.
So I did it mentally, so that's why it happened. Like I was looking at this, I do the same diagram. So instead of taking 30 as the base, I took 15 as the base. So it became 1 by 4 base into height.
Understood. Okay. Okay. Question 2. Triangle AOB. Blah, blah, blah. Okay. Anahat, what did you get on this one? Find the coordinates of the ortho center. Anath has starting
sorry,
trouble with his mic. Okay, yeah.
No, sorry.
You're okay.
Yeah.
Yeah.
It will just be 0, 0, right?
It'll be just origin, right? All of you good on this one? Fairly simple question only, right? So, I mean, just doesn't matter what the coordinates are. All right. So ortho center is the meeting point of the altitudes. So the altitude from A to BC will be AB itself. Altitude from C will be just CB itself. Altitude from B will be some line. All of them will intersect obviously at the ortho center. Okay. So by the way, on this one, can you guys quickly do what the location of the circumcenter will be? On the same problem, can you guys do the coordinates of the circumcenter instead of ortho center? I'll give you some time now. Shivank, did you catch up on the video from last time?
Yeah.
You remember the formula for the circumcenter, right? Here anyway, I'm not asking the circumradius. Yeah, anyone?
Oh, you were asking the circumcenter, not the radius, sir.
Fine. If you're able to find that also, great. In fact, I was going to ask that next. Yeah. So given that you are.
So I got the radius, but I forgot how to do the centers formula.
Okay. Okay. What is the radius, by the way?
6.5.
6.5. Okay.
Yeah, I
Anyone?
got 6.5 as well.
Okay. Yes.
And is the coordinates 6, 2.5?
That's correct. And what does that 6, 2.5 indicate in this problem? Where does it fall?
On the hypotenuse.
On the midpoint of the hypotenuse.
Midpoint of the hypotenuse.
Yeah. Okay. So yeah, Avinash, Yeah, well done, Abhihan. So this is the diagram, right? So you have this is the triangle 0, 5, 12, 0, right? So you have these 3 points, 12, 0. So what is circumcenter? Circumcenter is the meeting point of all the
Perpendicular.
meeting point of the perpendicular bisectors, right? Yeah. So
Yes.
yeah, so it'll bisect here, and it has to be perpendicular from here. Similarly, it has to be bisecting here and has to be perpendicular here. So if I draw just by midpoint theorem, right? So this will meet here, right? At this
Oh
midpoint.
yeah, it'll be 6 and 2.5.
Right. I mean, I didn't draw it perfectly here, but yeah, the midpoint theorem will show that. Yeah, you guys are with me. So, and also the circumradius, therefore, as you rightly said, will be half of the hypotenuse, which will be 6.5. 6.5, which is the half of the hypotenuse. In fact, for any right angle triangle, in fact, can you prove this? So prove that for any right angle triangle, the circumradius is half of the hypotenuse. Can you prove that? Again, proofs are all not there for AMC, but just so that the concepts are clear. So take a minute to prove that for any right angle triangle, the circumradius is half of the hypotenuse. Proving means you can just directly substitute the formula itself and see. You know the formula, right?
Yes, sir.
Yeah.
Yeah. So, so are you looking for an answer, or are you just seeing
No,
if
no.
you can-
Yeah, see, if you're able to prove it, that's good. Yeah, why don't you call out? How did you prove it, Apurva?
Yeah, so the formula for radius of circumcircle is ABC, where ABC are the 3 sides. So A into B into C upon 4 times the area of the triangle.
Exactly.
So you can write that as A into B into C over half in a right angle triangle, half into A into B into 4. And then in the denominator you get 2AB, and then when you cut it, you get C by 2, where C is the hypotenuse.
Perfect. Yes, makes sense, right? So ABC by 4 delta gives that. And you can see this in any picture, right? So in this picture, so this length will match this length, will match this length, right? You can see that visually also, you can see this, right? And you're able to complete a circle around this. Okay, cool. Okay, so by the way, on the altitude thing, I wanted to mention one point. So if you have an altitude for a right angle triangle, that will divide the right angle triangle into 3 similar triangles. Sorry. Let me get some space. Okay. So if I have a right angle triangle, let's say, we'll draw a large right angle triangle. I don't know why it's not so sensitive. Okay. Okay. So if I draw a perpendicular from here to here. Okay. So these three triangles will be similar. Okay. So let's say this is A, this is B, this is C, and this is D. Okay. So this is theta. Okay. So this is perpendicular. This is also perpendicular. Okay. If this is theta, this is clearly 90 minus theta. And therefore this is theta. And therefore this is 90 minus theta. And this is 90. So all of those 3 triangles, all the 3 triangles have the 3 angles as theta, 90 minus theta, and 90. Therefore, by A property, angle property, they are similar. A, you cannot use it for congruence, but you can use it for similarity. So same shape, but different size. Okay. So this means you can solve a lot of these knowing a few of these sides. So for example, okay, so let's say this is, let's call this is a small c, right? Opposite to capital C. And let's say this is small a, opposite to capital A. Okay, and obviously the hypotenuse is square root of a square plus c square. So that we know is B. Okay, so suppose we have to find out what BD is. Okay, so let's say we want to find BD. Let's call this H, right? So we can just use similarity of triangles. How do we do that? So if you do BD upon AB, right? So in each of these three triangles, you can see one which is a small side, one which is a medium side, one which is a long side, which is the hypotenuse, right? So you just have to put a corresponding one. So H is in the triangle ABD, in this triangle, right? H is the medium side and C is the longest side. So H upon C will be, if I go to the large triangle, the main triangle, the median side will be A, right? A looks like C looks like the smallest. A by B. B is the largest. So H is just AC by B. Does it make sense? Yeah. Avinash, are you with me?
Yes, sir.
Yeah. So similarly, suppose I want to find, let's say, CD. Okay, so CD, I'll just call this as X. Suppose I want to find CD. So I can use this triangle here and say X upon, so X is the medium side in the lower triangle here, right? Upon, let's say the largest side is A. Equating that to the main triangle, in the main big triangle, we have the medium side as A and the longest side is B. So X is just A square upon B. Okay, so like this, I can find any measurement that I want. So let's do one more. Can you guys find AD? Find AD in terms of small a, small b, and small c. AD. Okay, and then also find, yeah, I think that's the only one to find, right? Find AD. This is CD and this is BD. So I should say function of, right? It's not ABC, it's function of ABC in terms of small a, small b, small c. Yeah, anyone? Anahat, do you have anything?
1 minute.
Kunal? Done? Why? It should not take so long, guys. It's very similar to what we did for CD, no? If you understood what we did for CD, Apurva, any answer?
No, sir.
Okay. You know how to do, or should we go through? If you need more time, we can give. Should we discuss, guys?
I'm not able to understand it.
Okay. Did you understand CD, Kunsh?
Not
understood?
fully.
Okay.
So do you have to use that altitude ka formula or what?
No, you just have to use similarity of triangles. How did I find CD? Okay, I'll do AD now. Then this will be
Oh,
clear.
you can use similarity and find it, sir.
Which is how I did CD, right? Exactly like how I did CD. I'm expecting you
Oh,
to-
okay.
We found BD using similarity. We found CD using similarity. I'm asking you to find AD using similarity. There are three triangles. All of these three triangles are similar. The small one, this medium one, and the large one. All three are similar because all of them have three angles which are same. Shivank, make sense or?
Yes, I understood.
No, not clear, Shivank. You
So I've
understood
not
or
got an answer yet.
okay, but you understood the concept, right?
Yeah.
Okay, good.
So I got C square upon B.
That's correct. C square upon B. Okay, let's do it, guys, since we have spent some time, right? So AD, so where is AD? AD is in the small triangle. And I'm looking at this, right? So let's call this some name like Y, right? AD is Y. So Y upon, so the smallest, in the smallest triangle, Y is the smallest side. Upon the largest side is C, the hypotenuse, right? So that should match. In the large triangle, the smallest side is what? C. And in the large triangle, what is the largest side? B. And that's it. Therefore, Y is C square upon B. Does it make sense, guys? Is this
Yes,
clear
sir.
now, guys? Kunsh, you're okay? All of you? Shivank? Okay. So this is very important. In right angle triangle, once you draw the altitude, all the three triangles are similar, and this helps in calculating several of these sides very quickly. Okay, cool. You don't have to remember all of this. Don't remember, in fact, don't remember anything. Just remember similarity, bus, right? And then you can use it. Otherwise, it'll be too much pressure on you to remember this formula, that formula. Don't remember anything. I mean, of course, some of them you have to remember. For example, circumradius, in radius, all that. But in this, like, what is C square by B? What is A square? Tomorrow, if I draw a different diagram, all the A, B, C, and all will be ulta, right? So just remember similarity and how to use it. Okay. So that was question 2. Question 3. Shivank, were you able to do this one? The bisector of angle X,
Yes, I'm not sure, but I got 6 centimeters.
6. Okay.
Yep.
Okay. Anyone got 6 or something else?
So I got 1.
1. Okay.
Even I got 1.
Okay. So let's do this. So bisector of angle YZ. So this is YZ, right? This is the bisector of angle X, sorry. Bisector of angle X. Okay. So this is angle X, and this is Y, and this is Z. Intersects this at D. So this is D. And then the median intersects at E. So let's say I have a median here. So median goes from here to the midpoint, which is this. So this is E. Okay, so this is clearly, so YE is 6, not 6, 7, half of 14. Now YD, we have to calculate, right? So YD, we can use in an angle bisector, we have this property, right? XY upon, so this is equal to this, right? So XY upon XZ equal to YD upon DZ. So we know this, right? So this is given to be 3:4, right? So this is 75%. So let's say this is some 3A, this is some 4A, right? So which will mean this is some 3B and this is some 4B. Right? The ratio will be 3:4. But we know the total is 14. The bottom is 14. Therefore, 3B and 4B is 7 parts. So 7B is 14, which means B is 2, which means 3B is 6. So this portion is 6. Probably, Shivank, you found this,
Yeah.
and then you didn't read the question fully, right? So DE is just 6, 7 minus 1, which is 1. 7 minus 6, which is 1.
Hmm.
Yeah, makes sense? Fairly straightforward, just formula substitution only. Okay, question 4. In PQR, 30, 60, 90 triangle, side Q measures 10. Find the circumference of its circumcircle. Kunsh, what did you get on this one?
So for this one, I got
You got? And then it's suspense. He exited after he said he got. Okay, Vihan, what did you get?
So I actually thought 30, it wasn't 30 degrees. I thought I read it as 30 raised to 0. So I didn't
Come.
answer.
Oh, so you said 1, 1, 1 triangle, equilateral triangle. Okay, that's fine. Even then they'll have an answer, right? Oh, then, but you should have wondered the side measures 10 centimeter. Kya hai? 1
I was
centimeter.
just confused, so I didn't solve. I skipped this question.
I see. Okay. Come on, it's very obvious, right? 30 degrees. Okay, fine. Anyway, Apurva, what did you get?
So I got 10.
10. as the circumference. Find the
Yes.
circumference of its circumcircle. No pi and all, just 10. Okay. You would expect some pi somewhere, right? Because 2 pi r should come, right? Or maybe did you mean the radius?
So wait, let me just double check. I might have gotten the radius instead of the.
Okay, fine. Anyone got any other answer,
I
guys?
got 20 upon root 3. Pi.
20 pi. Okay. So 20 upon root 3, 20 pi upon root 3, like this, right? So whenever you call
Yes.
out, call the numerator fully. 20 pi upon root 3. That way, when you're dictating, someone cannot write it. You said 20 by root 3 pi. So someone could write it like this, right? So in general, have the habit of calling all the numerator together, 20 pi upon root 3. Okay, so yeah, I mean, at least this seems reasonable because there's a pi, right? But let's see. So 30, 60, 90, side Q measures 10 centimeters. Let's draw a simple diagram. So 30, 60, 90, which is a very popular triangle as we've discussed. So this is, which is P is the 30 degree, Q is 60, and R is 90. Side Q, which is the one opposite to capital Q, is 10. Okay, so you know the ratio, right? If this is X.
That's why I was confused.
This
about
will be X root 3, right?
Yeah, that's right. Kunal, what were you confused
How
about?
do you know? Like that's why I couldn't do the question. How do you know what is side Q?
Intentionally, I gave it like this because you should know, we have discussed this in class, that a smaller letter corresponds to the opposite capital letter. That's the convention, right? I could have very well given this as PR, but I did not because I wanted you to be aware and know, right? As part of doing this, that small q is opposite to capital Q. Does it make sense? Right? So that's how you're supposed to label a diagram. Of course, not always. I mean, so all good books label it properly, but in some of the books you might see that they don't follow this labeling. Of course, if you have a quadrilateral, you cannot do anything, right? So for example, let's say this is A, B, C, D, right? Then you don't have much choice. You have to clearly, I cannot say this is A, right? Who said this is opposite? This is also opposite. This is also opposite. How do I know which is A? So there I don't have a choice. I have to explicitly say. But in a triangle, the convention is opposite, right? Opposite to capital is a small. Okay, so anyway, back to this. 1 is to root 3 is to 2. So in this case, x root 3 corresponds to 10. So 10 is x root 3. Therefore, my x is 10 by root 3. So this is 10 by root 3. And this is 20 by root 3. Okay, now what I'm asking, find the circumference of its circumcircle. And by now we know, right? We just saw that the radius is, the circumradius is half of the hypotenuse, which is be half of 20 by root 3, which is 10 by root 3. And therefore, the circumference indeed is 2 pi into 10 by root 3. So you're right. Well done, Avinash. Okay, what is your mistake, Apurva? Did you find your mistake?
Not exactly. So I'm still working on it.
Okay,
I think I might have mislabeled this as like I don't think I took Q is equal to 10 as x root 3. I might have taken it as x or something.
okay, but makes sense, right? To you know.
Yeah.
Okay.
I used the ratio only, but I might have messed up in the calculation.
Okay. Okay. All right. Question 5. Okay, Shivank, you have something for this?
So I got the sizes 480 and 31.
Yeah,
Yes.
31, 480 and 481, right? Good one. Yeah.
So,
So
but it took a while to realize that it's a triplet. So, like, what can you do to solve
Yeah,
this
same.
question normally?
Okay.
Mine
Okay.
was a complete guess method. Like I assumed that 31 plus 480 would be.
Where did you come with 31?
So first I did 480 squared, and then I subtracted 481 squared minus. So it like took me quite some time, and then.
Okay. All right. Heard you.
Yes,
Avinash,
yes,
where did
So
you
even I
consume
did the
time?
same thing. I thought it will be a triplet because otherwise they won't give such a large number. So that's why I put it 481 square minus 480 square, and I hand calculated all of that. And
No,
then,
don't. Okay. So
with
why
that
did you,
PM and all.
okay, why did you guess that the other one is 482? Sorry, 480.
I first guessed 482, but then I changed.
No,
it
not
to
482, because longest one is the hypotenuse. That is 481. But why did
Yeah.
you guess the other side to be one
It
less
had to
than
be
this?
something near it. No, I just assumed randomly.
So why? What do you mean? We have 8, 15, 17 also, right? So
Yeah.
right? But
So-
the trip, yeah, go ahead, please.
So
Apurva.
I used the Pythagore the formula for like the 3, 4, 5, 5, 12, 13. I tried it with 2n square plus 2n plus 1. I solved the quadratic for 481 and then checked if it was working out. If that didn't work, then I would have tried the P and Q where P is greater than Q. But that's also complete guesswork as well. But first I did 2n square plus 2n plus 1.
Exactly, right? So what is this 2n square plus 2n plus 1? Just to recap, I can Avinash and others, Shivank, you also, right? I can start with any odd number. What is the square of 7? 49. I
Yeah.
find two consecutive numbers that add up to it. So, for example, 13 square is 169. I can find two consecutive numbers as 84 and 85.
Yes.
Similarly, I'm reverse engineering here. So 481 is given. So I can guess the previous one to be 480. I add these two, just like I added these two and got 169. I added these two, I got 49. If I add these two, I get 961, which you know is a perfect square, which is 31 square. So
Yeah,
you
that's what I
immediately put
did.
31 here. So you don't have to do
Cool.
any big
So
squares.
what's the formula? So it's 2n square.
So, okay, start with any odd number, like rather than give a formula, I'll just illustrate. Start with any odd number like 13, square 13, right? And split it into almost two equal halves, two consecutive numbers which add up to that.
And what about when there's 8, 15, 17?
Okay, that I'll come to. Is this pattern clear to all of you?
Yeah.
Right? Which is why I gave this 481 such that when you add to 480, it is a perfect square. It would not have worked had it been 471. Then 471 plus 470 is whatever 941. I did not give something like this because it's not a perfect square, right?
Yeah, so that's what I did. I just added both of them. So I first took 482 and I added it with 481, realized that's not a perfect square.
Yes.
Then I did with 480 and it worked out to be a perfect square. So I wrote 31 as well.
Exactly. Yes. Now, what is this other one that you guys were asking? So that is a more general way of generating a triplet is I can take any two numbers P and Q, and I can look at three numbers, P square minus Q square, 2PQ, and P square plus Q square. So that will be a triplet. Okay. But so in this case, we know P square plus Q square is 481, right? So 481 is P square plus Q square. If you are able to guess two squares which add up to 481, you're good. So right now, as I'm speaking, I can easily guess it's 481. So 20 square plus 9 square, right? So I can choose my P to be 20. Generally, P is greater than Q. P to be 20, Q to be 9. If I do that, what do I get? I get 2PQ to be how much? Okay, in fact, in this case, looks like there's another combination also, right? So 2 times 20 is 40. 40 times 9 is 360. Okay. And P square minus Q square is 400 minus 81, which is how much? 329, is it? 329, right? So that's also a triplet. So if you have your calculator offhand with you, can you just check if 329 plus 360, 329 square plus 360 square is 481 square? Can you check? You have a calculator with you guys? Any of you? Yeah, or just Google it and you can square it. 329 square plus 360 square. I want you guys to get convinced.
No, sir, they're not the same.
It's
is not-
487 point something.
Okay, so did I do some mistake? Then can you find my mistake then? Because 400 is 20 square. 81 is 9 square.
Sir, you did not subtract it properly. 319, not 329.
31. That's what I was asking. Did I subtract that? And you guys all nodded or didn't catch. Yeah, minus 81 would be 319. Now can you check 319 square plus 360 square?
Yeah, works.
It works, right? So turns out this is not the unique answer. Now, right? Does it make sense? So is there any other way of generating sum of two squares to give 481? Can any of you think of another way of generating addition of two squares to give 481? I'm also thinking. I also don't have an answer offhand, but let's think. Anything?
So 16, 15.
16 and 15, exactly. I was just going to say 16 square, very good. 16 square plus 15 square, right? Is 481, 256 plus 225. So what is 2 into 16 into 15? 2 into 16, 2 into 15 is 30. 30 times 16 is 480.
480.
So this is 481, and 16 square minus 15 square. 16 square minus 15 square, I can do 16 plus 15 times 16 minus 15, which is easy, right? 31. And that's the triplet, right? So there are 2 triplets ending in 481, at least 2. Maybe there are more, but who knows? You could have generated this also. So Apurva, you said first you will try this. If not, I'll try this, right? You didn't have to, because this itself, the easy one worked for you in this case, correct? But does it make sense, guys? It's a good one. I didn't realize that there's another triplet. I'll use this for some other problem as well. It's good, right? But the main thing I want to highlight is you should know all the perfect squares well, right? So if you see a number, you should be able to immediately identify. For example, you would have done 481 plus 480, 961 should not be a dry number to you like any other number. Immediately on seeing 961, you should know it's 31 square. So the practice of identifying squares when you see it, or cubes, or powers of 2, powers of 3, all of these special numbers, you should immediately know on seeing them. Okay, so that's the drill I want you guys to go through. Okay, that's question 5. Question 6. Okay. Okay, so here I'm giving some general information. First, let me just go through this. By the way, first let me just check answers on this. Anyone with an answer on this one?
4 by 3, 7 by 3.
4 by 3, 7 by 3. Okay, so yeah. See. Okay, what am I asking? I'm asking the centroid. Centroid is the meeting point of the medians, which is the center of gravity, right? And I've told, maybe I told you, I don't know, center of gravity. The coordinates of the center of gravity, or the coordinates of the centroid, are very simply the average of the 3 coordinates, right? So this is, let's say, x1, y1, x2, y2, x3, y3. Okay, so the coordinates of the centroid will just be x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3. But I did not give that information. It'll turn out to be this way. Now let's first check, right? And then we'll use this other method I told you, right? So this indeed is 4 by 3, and this indeed is 7 by 3, right? So you're right, Anahat. Okay, now, but I want you to get introduced to this other one, which is important, right? What is this? If I have any line, right? Doesn't have to be x-axis. I just said x-axis. If I have any line, and suppose I want to divide into 2 parts, let's say 1 is to 9. 1 part is to 9 part. Okay, so let's say I'll just give the coordinates of this is let's say 12. Okay, it's only x-axis, right? So I'll just say this is at point 12, and let's say this is at point 72, right? Something. Right, so I'll have to divide into 1 is to 9. Then clearly this the coordinate of P, right? The coordinate of P should be closer to 12 than to 72, right? So because I'm splitting in the ratio 1 is to 9. So the way I do it more generally is you give a weightage 9 parts to 12. And only 1 part to 72. So the weightage is more on 12. It's like a balance, right? So more weightage to the portion which is closer to it. So 9 parts weight to this first point, which is 12. And only 1 part weightage to the second one, which is 72, upon 9 plus 1, because I have to weight it, right? So it's a weighted sum. So think of it as a weighted sum. So 9 by 10 and 1 by 10 are the weights. So the weight 9 by 10 is applied to the one which is closer. The weight 1 by 10, which is applied to the farther one, which is why, right? Are you able to understand this one with numbers? With numbers, this makes sense, right? So instead of 1 and 9, suppose I make it as m and n, same thing. N parts to 12, right? Because that's the bigger one. And m parts to 72 upon m plus n. In other words, the weights would be n by m plus n and m by m plus n. The weights will add up to 1. In general, you see when I weighted sum, the weights will add up to 1, right? So what proportion to allocate to 12? So it's a mixture. It's a weighted mixture of 12 and 72, and more weighted towards 12 if it's a ratio like 1 is to 9, right? So which is why it's ulta. n comes to 12 and m goes to 72. Okay, so that concept I wanted you guys to understand, and using this we can still find the coordinates of the center of gravity and confirm it's the same, right? So let's do that.
What
So-
was the use of this formula that they'd given at the top? Oh, this is you just
So-
did that one.
Yeah. So in general, suppose there's some other problem where there's some line, and let's say this is given to be 2:5 ratio. How do you quickly find the coordinates of this? Let's say this is 7,17, this is 8,31. How do I quickly find this point? I can quickly do it by saying 5 parts to 7 and 2 parts to 8 by 5 plus 2, which is 7. That's the x coordinate. Does it make sense, Avinash?
Yes, sir.
Okay, so let's do that for this problem now. So okay, so the first is
So, but like for this, the both the points like where the line doesn't need to be on the same like y-axis.
yeah, they have to be on a line. What do you mean? Any 2 points will be on a line, right?
No, I mean like the same y-axis line. Like how in this question, both the points are on the x-axis.
Oh, no. That was just to illustrate. It can be on any line, it can be on any inclined line, doesn't matter. So you'll apply the same formula for the x coordinate, you'll apply the same formula for the y coordinate. That's it. So you'll treat them as independent thing. Does that make sense, Kunal?
Yeah.
Okay, so you're not very convinced. Let's see this. Okay, so first I want to find the midpoint, which is 1:1. So for 1:1, so this is -3, 0. Which is p, guys? P is whose coordinates are okay, this is p, right? So this is -3, 0. Find the coordinates. Okay, it doesn't matter which is okay, fine. I'll just take the bottom only as -3, 0. It's fine. Okay, -3, anyway, the answer should be same. -3, 0. Let's say this is 5, 0, and this is 2, 7. Doesn't matter. Okay, now for 1:1, you don't need any big formula. How do you find a point which is exactly halfway? It's just -3 plus 5 divided by 2, right? But where is this formula coming from? It's coming from this -3 getting multiplied by this one, and the 5 getting multiplied by the other one, right? Even though both are 1 in this case, upon 1 plus 1. That's how you get the average, -3 plus 5 by 2. So which is 1, right? So this point is a 1, 0. Now I'll apply, I know that the center of gravity is 2:1. It splits this in the ratio 2:1. We've seen that in the past, right? So the G, right? PG is to GD. Let's say this is D. PG is to GD is 2:1. We've covered that in the past, right? So now this is where I want to apply the ratio 2:1, right? So which means, okay, so what are the 2 points? 2, 7, and then the other one is 1, 0. Now let's say I have a line like this. I want to find something which is closer to this, like this, right? So this is 2 parts, and this is 1 part. So which means, right? So for the x coordinate, I'll apply this 1 weightage with this 2. So 1 part of 2 plus this 2 weightage with this 1 plus 2 parts of 1 upon 1 plus 2, which is how you get 4/3 as the x coordinate. Is this clear, guys? Kunal, are you with me? Make sense? Kunal.
So can you just repeat it? Oh, so 2 is just 2, 7, 1, 0. So you
Are the 2 points.
and
Now,
2 and 1, and then, so
So can
that's
you
why
use
1
like
into 2.
different
2
values once we can?
Okay, so I'll use completely different values. So for example, okay, fine. Let's say I have 3, -5. Okay, and let's say I have 6, 12. Okay, and suppose I have to split it in the ratio 4:3. 4 parts is to 3 parts. I have to find a point which is P, which is 4 parts is to 3 parts. This is okay. Okay, so 4 parts is to 3 parts. Okay, so this is P and this is A, this is B. Okay, so first what will I do? I'll first focus on the x. Whatever I do for the x coordinate, I'll do the same for the y coordinate. So 3 and 6 are the x coordinates. So it's going to be 3 times something plus 6 times something upon that something plus something. So this is what is the weight. So associated with the 3, oh my God, I just put this as 3 as well, right? Okay, fine. Associated with this 3 is this. Okay, fine. I'll just change this number to 2. No, to 4:2 will be Okay, I'll change this ratio to be, how about 5:2? Is that okay? So in the ratio 5:2. So this 3 goes with the weightage of 2.
How is it like that?
That's what the formula said, right? N times P, N times the first one plus M times the earlier one.
Okay.
We just went over, right?
Yeah,
I mean, I'm not giving you the proof for this, but I'm just telling you this,
so
right?
that's just from the formula.
Yeah. So 3 times 2, and then 6 gets associated with this weight. So it's ulta. So 6 times weight, and upon the sum of the two weights, which is 5 plus 2.
Wait, so will it always be connected to the opposite one?
Correct.
Oh,
I told you that also, because if I have 1:99, for example, you want the weight of 99 to appear to the one which is here, right? So for example, you want a weightage of 99 to appear towards A, because only then the P will be closer to A, right? You understand? So the weightage here would be 99 times A plus only 1 times B upon 100, which means the resulting point P will resemble A much more than it will resemble B. Are you guys understanding? Vihan, you're with me? Yeah, all of you with me? Anyone still doubt? Anahat, your video is off, beta. You're okay?
That was my mistake. I'll done.
Okay. Kunsh, at some point you dropped off. In fact, it was during the time when you were going to state an answer, but I don't know when you joined, but all okay? Kunsh?
Yeah, it was just some Wi-Fi problems. It's all okay now.
Okay, all right. So back to this problem now. So, right. So I want to verify. Sorry, where is this now? Okay, so back to this problem. Let me just, so right now I'm redrawing, this is P and this is D, right? P and D. So this is my P, which is 2,7, and this is my D, which is 1,0. So 2,7 and 1,0. And I know that this guy, the G, which is the center of gravity, right? Or the right, divides, or the centroid divides in the ratio 2:1. So the same logic. So this one goes with this 2. So 2 times 1 plus this 2 goes with this. Yeah, unfortunately, there's too many 2s and 1s here, right? Upon 3. Or rather, I'll just put 1 times 2 so that you know which is the weight and which is the number, right? So 2 is the weight and 1 is the number, right? Plus 1 into 2. So which is your 4/3. Similarly, if you want to find the y coordinate, I'll do the exact same thing. Just erase and make some space. You have to find the y coordinate. Same 2:1 ratio. So this weightage of 1 goes with this 7, right? So 7 times 1 plus this weightage of 2 goes with this 0, right? So 0 times 2 upon 1 plus 2, which is 7/3. Does it make sense? So I got the coordinates as 4/3, 7/3. But after doing all this, right, all this was not needed if you just knew that the coordinates of the centroid is just the average of the 3 coordinates, right? X1 plus X2 plus X3/3, Y1 plus Y2 plus Y3/3, as I told you, coordinates of the centroid. But I wanted you to learn this, how to split any random line in a ratio M:n. That was the main learning from this. We applied it twice. Once to divide the bottom into ratio 1:1, and once to divide the median itself in the ratio 2:1. Okay, Apurva, you're with me completely? Okay, good. Any doubts, guys? Anyone else? Okay, question 7. Perimeter of a triangle is 30. If each side is an integer, what is the maximum? Okay, I'll just more. Perimeter of triangle is 30. If each side is an integer, how many different triangles could be drawn? If 2 triangles are congruent, they are counted as 1. So by this, what do I mean? I mean, if I have a triangle which is 16 centimeters, 12 centimeters, 8 centimeters, and 10 centimeters. In another triangle, it's 8 centimeters, 12, and 10, or 8, 10, and 12, right? It doesn't matter which side I'm going to call 8, 10, and 12. I'll consider all of them as one triangle. So with that premise, how many triangles are there is the question. Okay, Avinash, we're able to get an answer on this one.
Yes, so I got 15 triangles, and the greatest area one is the equilateral.
Okay, 15 triangles. Okay, anyone else got anything? 15 triangles or less or few? Okay, Apurva, why are you nodding your head?
So I got an answer for the area, like the max area is 25√3, which is the equilateral. I did not get an answer for a number of
Okay,
times.
but why is it that for equilateral it's the maximum area? How do you know that?
So
That I knew as a rule only, sir.
yeah,
Okay.
same. So, but like if I was guessing, I'd probably say because of Heron's formula, when the S minus A, S minus B, S minus C terms are always the greatest in an equilateral triangle, because each term is like, so for example, even in like in a right angle triangle or something like that, if you use Heron's formula, even if the perimeter is the same, each term, like S minus A, for example, I need to think of an example.
No, okay. So I hear you, but you're partially right, partially wrong. So S minus A, S minus B, S minus C, depending on A, B, and C, right? So for example, if A is small, right? A is 3, and B is 4, and C is 5, right? And this is 4, this is 4, this is 4. We are comparing these two triangles, let's say, right? In one case, S minus A is large, S minus C is small, S minus B is medium. Whereas in the other case, all three are same. So it's not like consistently in an equilateral triangle, all the three terms are large. It's just the product as a whole becomes large in an equilateral triangle. Does it make sense, Apurva?
Yeah, so but it's also like, for example, if you're using 12 into 12 is greater than 11 into 13 by 1. 11
Exactly.
into 13 is 143, whereas 12 into 12 is 144.
Exactly.
So,
Yes, correct. That's a better example, right? So given a sum, so a general rule of thumb is this. So given a sum, a product of few terms will be maximum when the terms are all closer to each other, right? So similarly, so exactly like what you said, right? So 11 into 13 is smaller than 12 into 12. And this is even smaller than 10 into 14, right? So the sum in all these cases is 24. But as the numbers go apart, the product becomes smaller and smaller. Okay, so that's exactly what's happening in the Heron's formula, right? You have S, S minus A, S minus B, and S minus C. So if S is anyway common, so if I'm comparing two triangles with the same perimeter, so given that the perimeter is the same and I'm comparing two different triangles, S is anyway S, it's not going to be it's not going to change. You only can change the allocation of small a, small b, and small c. When you do that, if let's say A is small and B is medium and C is large, then S minus A, S minus B, and S minus C are farther apart. I mean, are apart, right? S minus A becomes the largest because A is the smallest. S minus C becomes the smallest because C is the largest. But if you bring A, B, and C closer to each other, as in the extreme case, if you make A, B, and C all equal, then all of these three numbers will be equal, right? And the sum of all of these is constant. If you look at S minus A, forget S for a second. This S is anyway a constant. If I add S minus A and S minus B and S minus C, what do I get? I get 3S minus A plus B plus C. A plus B plus C is what? That's a 2S. So 3S minus 2S is S, which is a constant, right? So for a given problem where the perimeter is constant, then the closer we bring S minus B, S minus B, S minus C to each other, which means the closer we bring A, B, and C to each other, maximum area occurs. And therefore equilateral triangle. We can take it a step further and say, if I have a given perimeter between an equilateral triangle and a square, the square will have a larger area. Between a square and a pentagon, the pentagon will have a larger area. And so on. Given a perimeter, if I have to encompass the largest area, it will be a circle, right? And the smallest area will be in a triangle. So in other words, the more symmetric and rounded the picture looks. So triangle still has these sharp edges, right? It's not well-rounded. Square is slightly better well-rounded. This pentagon is looking more like a square, more like a circle. And if you have a 100-sided polygon, which is looking more and more like a circle, an infinite-sided polygon is a perfect circle, right? So this will have the maximum area. We can just test it, right? So it's a good test. So let's say the perimeter is constant, P, for all of them, right? So this will be, each side will be P by 3 in this case, right? Each side will be P by 4 in this case. Each side, but let's first test just the extremes first. We can test for a triangle. For a triangle, the area is √3 by 4. So this is given to be a constant. The same perimeter. So you have a rope, right, of certain length. you have to encompass an area. That's your area, let's say, right? So if you're clever and encompass a bigger area, that's yours, right? So root 3 by 4 times side square, which is p by 3 whole square. So how much is this? P square times root 3 upon 4 times 9, 36. So it's p square times root 3 upon 36. That's the area of a triangle. Now come to the other extreme end. Let's take a circle. Yeah, anyone had a doubt? Kunal, you're saying something? Okay, so you're unmuted for a second. I thought you had a question. Okay, so the 2 pi r, the circumference is my perimeter, right? Which means my r is p by 2 pi, which means my area in this case is pi into r square. So it's this, right? So which is p square into, one of the pi's will get cancelled, or p square upon 4 pi. So the comparison right now, p square is anyway common, right? Its comparison is root 3 versus 36 on one hand versus 1 upon 4 pi in the other hand, right? So we can either take a calculator and just compare. So, or you can just compare, right? This is 9, right? So let's cross multiply. So 9 on one hand, if I multiply this, both sides by 9 pi, it's comparing pi root 3. So this is the triangle equivalent and this is the circle equivalent. I'm comparing two numbers. I'm not saying which is higher. So this is effectively a comparison of pi root 3 versus 9. So clearly pi root 3 is smaller, right? This is 3.14 times 1.7, whereas this is 3 into 3, right? 3.14 is only marginally bigger than 3, whereas 1.7 is substantially smaller than 3. So clearly the circle wins. So like that, you can easily show that each of these areas will go in this order. So summary, given a triangle, a scalene triangle has a lesser area, and then isosceles will have a better area. The equilateral will be the best area, highest area. Given all of them are regular, a regular triangle as an equilateral triangle, a regular quadrilateral as in a square, a regular pentagon, and so on. In that comparison, the circle will win. So more rounded the object is, higher area it will encompass. Okay, now that was the area part, but how many triangles? This guy got 15, Avinash got 15. Anyone else got any number? Or will Anna, did you get something? Did you work this out? Or Kunal, what about you? Kunsh, why is no one opening their mouth?
Yes, I got 15 too, because like I use that property of triangle.
What property did you use?
Like that the sum of the two sides must be greater than the sum of the third side.
Sum of the two sides must be greater than the third side, not sum of the third side. There's only one third side, right? Sum of two sides is greater than third side. Okay,
Yeah.
go ahead. Can you expand? How do you get 15 then? So sum of two sides is bigger than third. Okay.
So like if we take the value of the sum of two sides to be like 15, then it's not possible, because then the
Okay.
third side also 15. So the
Okay.
sum of two sides must be 16 or greater. So 16 all the way up till like it will be up till 29. So that is 15 values.
Okay, but so
No, so that wouldn't work, right?
yeah, exactly, right? So
Because
if
sum
it's-
of two sides all the way up to 29 you can't have, because the lowest it can go is to 20. It can go as much till 20 only, because after that it goes back to the congruency, right?
But even with this argument, Kunal, so even assuming you have 16 as the sum of two sides, and the third side is 14, let's say, right? That's what you mean. The third side is 14, right? The
Yeah.
16 can be 8 plus 8, it can be 9 plus 7, it can be 10 plus 6, and so on, right?
Yeah.
So don't you have to count them as separate triangles? Does it make sense?
Yeah.
Yeah.
Wait, so then it becomes even more than 15, right?
Right, but maybe like Avinash just was saying, maybe some of them are not possible. Okay, so let's do it in a systematic fashion. Okay, so first let's eliminate. Okay, I'm not saying 15 is right or wrong. I'll just we'll erase this and see what we get. Right, so we can split into three categories. Right, we can have equilateral triangle, we can have isosceles triangle, and we can have scalene triangles. Okay, equilateral triangle is very easy. There's only one, 10, 10, 10. So I'll just put one here. Okay, isosceles triangle. Okay, so there's two sides and a third side, right? So can we have 1, 1 and 28? We cannot, right? Because 28 is bigger than 1 plus 1, right? So similarly, I can all the way going to 7, 7 and 16. I cannot, right?
So you have to start from 14.
Correct. We have to,
See.
or rather 8, 8, and so all of this is not possible. I'm just listing it so that you guys are understanding. So In an exam situation, I would not even do all this, right? Just for explaining, I'm saying. So the starting point will be 8, 8 and 16. 8, 8 and 14, I'm sorry. 8, 8 and 14. Okay. So the next one would be 9, 9 and whatever, 12, and so on. So the large, and then this goes on till 15, 15 and 0 is not possible. 14, 14 and 2 is possible.
7 of
Right?
them.
Sorry, there are, yes, 6 plus 1, which has 7 of them. But you should bear in mind that 10, 10, 10 came beach mein, which is already counted here, right? So either you don't count this separately, we'll count this only and we'll count it as 7, right? Or you do whatever it is, right? So you can just say equilateral and isosceles. One of them is 1, but in total, this is 7. Does it make sense? Yeah. So 7 of them in this category. Now the scalene category is, we can safely say one side is bigger than the other side, which is bigger than the third side. This gives us a lot of flexibility. So let's start with, like, back to what Kunal was saying, right? The highest can be only is 14, right? Right, it cannot even be 15. If this is 14, these two should add up to 16, right? So which means the starting point is 13 and 3, correct? If this is 14, then this is 13 and 3, or it can be 12 and 4, or 11 and you don't have to list all of them. I'm just saying, just the pattern, right? So 11, 5, all the way till where it cannot be 8 and 8, because we want B to be strictly greater than C, because we are counting only scalene. So
So
all
9 and
9 and 7, correct? 9 and 7. So how many of them in this category? We can just hand count. 9 to 13 is 5 numbers. So far 5. Okay, and now that's the 14 series. Let's go to the 13 series. So this is 13. This has to be 12. First of all, the sum of the B and C should be 17, right? So 12, 5, 11, 6, all the way till 9, 8, right? How many are there in this? 9, 10, 11, 12. There are 4 of them in this. Okay, so we can quickly finish this, right? It won't take too long, right? And similarly, let's do the 12 series. If this is 12, the largest one is 12, then the semi-largest should be 11. We need a total of 18. So it will start with 11, 7 and 10, 8, and that's it, right? There's no 9, 9. Okay, there are only 2 of this category. So you can see it's drastically reducing, right? So now if this is 11,
There'll just be 1.
exactly, has to be only 1. So we just have to add 5 plus 4 plus 2 plus 1. That's it, right? There's no 10, 10, 10 anymore. 10, 10, 10 is already counted, right? 5 plus 4 plus 2 plus 1. So the total number of triangles is whatever this is, right? 3, 7. How much is this, guys? 12.
12.
Plus 7, right? Total of 19. This is how we count. Does it make sense, Kunal and others? How do you systematically count? Apurva, make sense?
Yeah.
Okay. Avinash, you had a comment? Or you
Yes,
okay?
sir. So this, those triangles with 11, 11, 3 and all are valid, right?
Yeah,
so
yeah.
11, 11 and what would be the third number in it? 8.
8. Yeah, that'll come here, right? Somewhere
Oh,
here.
those will all be valid, right?
Yeah,
So
that'll be valid. So
how do
starting
you
with 8, starting with 9, starting with 7, 11, 12, right? All of them are counted here in this. 11, 11, 8 came here.
Okay.
Yeah. Okay. Now, okay, let me give an extension to this same problem, right? Suppose, okay, suppose I'll call the triangle as AB, BC, and CD as 3 different sides. Sorry, AB, BC, and AC, sorry, or CA. Right? These are 3 different sides. Okay. And so, for example, in one situation, AB is, let's take some random example, right? Let's take this example where it's 12, 11, and 7. AB is 12, BC is 11, and CA is 7. Okay. In another situation, suppose AB is 11, BC is 7, and CA is 12. Suppose I consider these two as 2 different triangles, right? So, which is not the question given, but an extension to this question. If I'm going to consider these 2 triangles as 2 different triangles, which means I have a number associated with each side. You understand the difference, right? Then how many triangles will be there? Can you guys work it out? How do you do this one?
Can you just repeat the question?
Okay, exactly same question, except that if 2 triangles are congruent, I'm saying they're counted as 1, right? In this original question, I'm saying this condition is now removed. So I'm going to count these 2 triangles as separate triangles now. Do you understand? Apurva. Okay, everyone. Now, obviously, there'll be a lot more triangles because, as we saw, right, earlier we were counting both
And
as
so
same.
then even
Yes,
oh
Vihan.
yeah. So then even AB, if you and then you count AB as 7, BC as 11, and BC as 12, and CA as 11 as a different one.
Correct. Exactly. Yes. I just gave an example of 2, right? There could be other. Yes, as you rightly said, it could be another one where AB is 7 and BC is 11 and CA is 12 is another one, right? So if I do that, then how many triangles will that be? So the approach to that problem will be exactly same. You'll first assume they're counted as 1, and then you'll be
Yeah.
able to easily build upon this.
Do you have to multiply it by 3 or you have to do that NCR?
Okay. You think and let me know. Yes, think.
So I got 93.
Okay.
No,
More than the
sorry,
answer,
no,
more than the
sorry,
answer,
sorry,
I want to
no,
know the
90.
approach. Sorry.
Yeah.
I got 91. So should I say the way I did it?
Okay, one sec. Let's give everyone some time. I'll list out all the answers meanwhile. 91, 93. Okay, go on, guys.
No. So 91. Yeah. 91 is right.
Okay, someone said 93. So you're removing 93 now? Okay.
Yeah.
91. Okay, all right. Let's give one more minute for everyone to think.
Yeah, same.
Yeah.
Okay. Yeah. Apurva, you're going to say 91 how, right? Yeah. Tell me, please.
So basically it's the same thing, right? The number of triangles are the same, but you need to think about the different permutations, how you can rearrange the triangles that you have.
Yes.
So for the scalene triangles where A, B, and C are all different, there are 6 ways that you can have different triangles there.
Correct.
So we add 5 plus 4 plus 2 plus 1, which is 12 scalene triangles. So 12 into 6, 72. Now scalene triangles.
Perfect.
Then
Hold
now
on,
you have to step-
hold on one sec right here. Do we all agree? Anyone debating that? So it's not 3, Avinash, it's 6, right? Given 3 numbers, I can permute them or arrange them in 6 ways, 3 factorial ways. Does it make sense?
Okay. Yeah. Oh yeah. Yes.
Right? It's just like arranging an alphabetical order: A, B, C, A, C, B, B, A, C, B, C, A, C, A, B, C, B, A. Yeah, go on, Kunal.
yeah.
Sorry, Apurva. Yeah.
Yeah. So now you have to separate equilateral and isosceles because equilateral will remain 1. However, isosceles, there are 6 triangles. You can arrange them in 3 ways each. So 6 into 18.
Yes.
Plus
Why 3 ways here? Because it's
Because
9,
two of
9,
them.
and 12. We just have to choose which is the one which is different, right? So let's say 9, 9, 12. We have 3 choices of saying which is the side which is different, right? Not 6 ways, but 3 ways. Yeah, brilliant. Very, very well explained. Yes, there are 6 of them in this category where each of them can get counted thrice. So indeed, it's 91. Yes. Whoever else got 91, did you do the exact same thing? Kunal, was that
The
you?
same thing. Yeah, I got 93
Nice.
before because like I had counted the equilateral also with that. Then I realized later.
Understood.
Same
Understood.
thing.
Very well done, guys. Yeah. Makes sense. Everyone clear? Shivank, you're okay on this one?
Yeah.
Okay, that was question 7. Question 8. Okay. Kunal, did you do this one? Did you get an answer on this one?
I couldn't do it.
You couldn't do it as in no time or don't know?
No,
Which-
I didn't get it.
Okay. Again, which means don't know how to do, right? Just to be clear.
Yeah.
Okay, all right. I just want to understand. Vihan, did you get an answer on this?
No, sir, I didn't understand this.
Understanding में क्या है? Simple.
Like, I couldn't solve it.
So
Why?
I got 5:12.
5:12. Okay.
Yes, sir, same. Even I got 5 is to 12.
Yes, sir. When I got yeah. Yes, sir. I got 108 is to 45. I didn't simplify it, but yeah, it's 5:12.
108 is to 45.
Yeah, sorry, 45 is to 108.
The ordering should be important, right?
Yeah.
So I'm sure in the exam paper, 12 is to 5 will also be a choice, right? So always be
Because-
careful which by which.
I don't
Right.
know. Didn't say right which one is.
No,
first.
it did say, right? What is the
Oh, okay.
ratio of the area of one trapezoid to the area of the inner triangle? So trapezoid
Oh,
upon the
okay.
inner triangle.
Yeah, so then it'll be the other way.
Okay. So Avinash, why don't you explain? What did you do to get this?
So I first did the area of the triangle using Heron's formula. So it's equilateral. So you just do x into so I took each side as being x of the
Of-
big
of- of the-
triangle.
Of the big triangle. Okay, this is
Yeah,
X.
and
Okay.
this the inner triangle is 2 by 3x.
Okay.
So for the area of the inner triangle, I did x. So the semi-perimeter of the inner triangle will be x. So
Okay.
therefore,
Okay.
no.
You can do that, but given that it's an equilateral triangle, you don't have to rely on this Heroin's formula every time. Heroin's formula is more for scalene triangles where the three sides are different. For an equilateral triangle, know that the area is just √3 by 4 into side square, right? Whatever x is the side, right?
Okay.
This Heroin's formula will also give you the same thing. It's too much. It's an overkill for a equilateral triangle, right? Doesn't make sense. For example, if you have a 5, 12, 13, which is a right angle triangle, will you do half into 5 into 12, or will you do root of s into s minus n, s minus b, into s minus c? You'll do half into base into height, right? The Heroin's formula will still work, but it's the one that's just fastest. Okay.
Okay.
So okay, sounds good. So you did that. You got an area for the inner one.
Yeah,
and
I
then,
got 1 by 9 x square 1 x square √3 upon 9.
okay, whatever. I'm not writing. And then process wise, you got that. After that, what did you do?
I found the area of the outer triangle.
Correct.
Again, using Heron's formula, but I could have used the method you said.
Fine. And then
I found the area of, so area of one trapezoid will be outer triangle minus inner triangle upon 3, because there are 3 trapezoids which are all the same.
correct.
And then I just put
Okay.
them.
Understood. The method is
Yeah.
perfect. Any faster method, guys? Apurva, did you do the same thing, or Anahat, did you do the same thing, or anything faster?
So same thing, area of
Same
larger triangle, subtract
I
area of
mean,
triangle.
So I
Yes.
had
Shivang,
like,
go ahead.
this question was there last year, right? So when I was correcting my paper, I had
Yes.
done it. So
Go ahead, Shivang.
I
How
mean,
did you do it?
because so basically the equilateral triangles are similar. So if they've given you the ratio of their sides,
Perfect.
that will be the ratio of the area. So you don't need to calculate it.
Okay. Can you describe, please? Yes.
Yeah, so I don't have my working with me right now, but because it's the ratio is 3:2, the areas ratio will be the square,
Perfect.
be
Yes.
9/4, and then so then yeah, so the ratio of all the trapezoids will to the inner triangle will be, I think I did like some
That's fine. That's fine. I can complete it for everyone. Okay.
Yeah.
So basically what he's saying is an important property with similarity. Okay. Forget this picture for a second. If I have two objects, if I have two random objects, okay. So in fact, I'll just go down and draw. Okay. Okay, fine. I'll just do it here. Some object, right? And if I have another similar object like this, right? If the ratio of the sides is 1:k, let's say these two objects are similar, right? So if a ratio, the lengthwise, the ratio is 1:k. So if this is 1 unit and this is k units, then area ratio will be k square is to 1 square, right? Or k by 1 whole square, k square is to 1 square. So in a linear dimension, if the ratio of two similar figures is k is to 1 or a is to b, whatever, then the area ratio will be k square is to 1 square or a square is to b square. Whatever the ratio is, you just have to square to find the area. And you can extend it to volume also. The volume ratio will be k cubed is to 1 cubed if it's a 3-dimensional object. For example, let's say you have a dad and then he has this little son here, right? Let's say the dad is, I don't know, I'm just making up some 2 meters, a very tall guy. And this guy is just born or something like maybe, I don't know, what's a good one, 40 centimeters. Okay, so the ratio is 5:1 in the linear dimension. 5:1 in the linear dimension, right? Or maybe I'll make it more reasonable. 50 centimeters. 50 centimeters. So the ratio is 4:1 in the linear dimension, which means volume wise, the ratios will be 4 cubed is to 1 cubed. And volume is roughly equal to weight. You can see like any human body, the density is same. So the dad will weigh 64 times the little son. So let's say the son weighs 2 kilograms, just born, newborn baby. The dad will weigh 128 kg. Again, I'm just being very rough here, right? But main point is volume wise, it's cube. Surface area wise, it's 4 square is to 1 square. If the linear ratio is 4 is to 1. Okay, so that's what Shivank is using in this case. So he's saying the smaller triangle to the larger triangle, the ratio is 2:3 in terms of the side lengths, which means the area ratio will be 4:9 parts. 4 parts is to 9 parts, which means all the 3 trapeziums put together, the 3 trapeziums are the difference between the large and the small, right? So the 3 trapeziums will account for 5 parts. Right. So this is 4 parts, this is 9 parts. All the 3 trapeziums account for 5 parts, which means each trapezium is 1/3 of that. So 5/3 parts. So now we just want the ratio of 5/3, which is 1 trapezium, to the inner triangle, which is 4 parts. So 5/3 upon 12, which is 5 upon 12. Does it make sense, guys? Right? I don't have to do x square. I don't have to do Heron's formula. I don't have to do √3/4 into sine square. I can avoid a lot of this just by using similarity. Does it make sense? Well done, Shivank. Bad that you were not able to explain it fully, but I understood what you're saying, right? Makes sense. Okay, everyone clear on this one? Kunsh, you're okay? Understood this property? Anahat, did you do the longer way or did you do something with scale factor?
I did an extremely long way. So.
Extremely long way. Okay, there are other extremely long ways as well, right? So, but they're all okay. Let's do in some other way also, just to illustrate a few more concepts. So, for example, I could use 30, 60, 90 property here, right? So again, this will be long, but at least it'll tell you how to apply, right? So, for example, I can clearly see that this is a 30, 60, 90 triangle. I can use that. How can I use that? Let's say I start with like one of you guys, right? Let's say this is 2x, or I'll just call it 4x, so that this is 6x. Okay, 4x and 6x.
So how do you know that's 30, 60, 90? Because
this is all symmetric, right? So this is like an angle bisector. You can feel it's 30, 60, 90. Can't you? Because all of them are equilateral. All of them are symmetric. They have to be right. Just by symmetry, you can see, right? So this is the balance 4x is x and x here. So the bottom is 6x, right? Now, if I blow up this separately, this is the bottom is your x, right? This is the x. And this corresponds to one opposite to 60 degree, which is, this is your, so you remember the ratios, 1 is to √3 is to 2. Therefore, this has to be x by √3. And this has to be 2x by √3. Okay, so you're okay with this one, right? How the one opposite to 30 degree is 1 by √3 of the one which is opposite to 60. The ratio is 1 is to √3 is to 2. 1 corresponds to the 30 degree wala, √3 corresponds to 60 degree wala, 2 parts corresponds to the 90 degree wala, the hypotenuse. Okay, so now I know the height of this trapezium, which is x by √3. Now I can use the area of the trapezium is height times average of the 2 bases. That's the area of the trapezium, right? Average of the 2 bases. So which is, how much is this? 5x, right? Average is 5x. So 5x square by √3. So that's the area of trapezium. And now I can use area of this small triangle is √3/4 into side square. So this is 16x square. So which will be 4 √3 into 4 into x square. Now I can find the ratio of this, right? So 5x square by √3 divided by 4 √3x square. So x square gets cancelled. I get 5 by 4 into 3, which is 12. Right. But again, this illustrates how I can apply 30, 60, 90 and find any side length. Right. Does this make sense, Kunal? How I can find the height of the trapezium. Okay. Anahat, you want to share your method as well? Even if it's long, it's fine. All methods you should learn, right? So that
So
in some other
basically
situation,
I just found the height of the big triangle, and then found the height of the small triangle and subtracted. And then I knew that the side length plus the height of the trapezoid would be, I found like L square, the side length of the trapezoid minus the height of the trapezoid is 0.25. And then the sum of the two is √3/2. And then from there, I just did a bunch of calculations to find everything.
Yeah. Okay. Fair enough. Yes. But yeah, it's good to have multiple perspectives. Okay. So that was question 8. Was that the last one or was there one more? Yeah, that was the last one, right? Okay. So let's continue. I just wanted to do a few properties on circles, on quadrilaterals and circles before we wrap for today. So let me get more. Okay, so quadrilaterals, you guys know all this, but just to be on the same page. So I can start with any quadrilateral here, a generic quadrilateral, right? The first division coming from a quadrilateral is a trapezium. A trapezium is where you have one pair of opposite sides which is parallel, right? One pair of opposite sides is parallel. So as a result of this, the base angles, sorry, not the base angles. The top angle and the two angles which are marked here will be supplementary because they are co-interior angles. Okay. Now from a trapezium, I can have an isosceles trapezium, which has a property that the two bases, or rather the two base angles are same. Not, I shouldn't say the two bases are same. The two base angles are same because that's a different restriction. The two base angles are same. As a result of that, the two bases become same, right? I cannot say the two bases are same because if I just did that, if the two bases are same, not bases, I keep saying bases, legs, right? If I say the two legs are same, then I can also have a parallelogram. A parallelogram is also a trapezium. The trapezium requires one pair of opposite sides to be parallel. It does not say the other pair should not be parallel. If the other pair also happens to be parallel, so be it. It's a special trapezium. So parallelogram is a special trapezium where the two legs are still same, but the two base angles need not be same. The two base angles here are supplementary. So both an isosceles trapezium and a parallelogram are special trapeziums. Okay, right? And then, so what is special about an isosceles trapezium? The two diagonals will be same. The two diagonals will be identical, right? And what is special about a parallelogram? The two diagonals will bisect each other. Two diagonals will bisect each other. This will be this will be this. They won't be same length, but they'll bisect each other, which is not true in a regular trapezium, isosceles trapezium. And then a rectangle is something that derives both from an isosceles trapezium and a parallelogram. So an object which is both a parallelogram and an isosceles trapezium has a name called rectangle. Okay. Now in the family tree, we also have a rhombus, which is a special parallelogram where the adjacent sides are equal. So in a parallelogram, the opposite sides are equal, but the adjacent side also happens to be equal. That derives a special name called rhombus. So what additional property does a rhombus have, which is not necessarily true in a parallelogram? That the diagonals are perpendicular. If only I can draw it well, right? The diagonals are perpendicular in a rhombus. And in rectangle, the diagonals are equal in length. And that has to be true because a rectangle is also a child of an isosceles trapezium. In an isosceles trapezium, the two diagonals are equal in length, and therefore in a rectangle also they're equal in length. In a parallelogram, the diagonals bisect each other. Therefore, in a rectangle also the diagonals bisect each other. Okay, so a rectangle derives both from a parallelogram and an isosceles trapezium. And a rhombus, the diagonals are perpendicular. Now comes a square, which is all hunky-dory, which is the best combination of rectangle and rhombus. So it has all these nice properties. And then the only object that we are missing in this is your kite. So kite would sit somewhere here, right? So it's like equal status as a trapezium, right? So it derives from a random quadrilateral. The kite has the property that you have two pairs of adjacent sides which are equal. So you have one diagonal bisecting another diagonal, right? And the diagonals are perpendicular, right? The other diagonal need not bisect. If it does, then it becomes a rhombus. So rhombus is a special kite, right? So rhombus derives both from a parallelogram and from a kite. Okay, and whenever the two diagonals are perpendicular, you can use the formula half d1 d2 for finding the area. So the area for a kite is half d1 d2, which you can apply for a rhombus also because rhombus is a special kite. Okay, all of this just revision, right? All of you know these properties. Just wanted to make sure that we have covered this, right? Now let's move on to circles. So let me just draw a circle here. Okay, so the main property in a circle is if I have any chord Okay, so if I have any chord, okay, and if I connect it to the center, so from the center, if I draw a line which is perpendicular to the chord, it'll be bisecting the chord. So if I have this is perpendicular, then it'll bisect the chord. Okay, and similarly, if I draw from the center of the chord to the circle center, that line will be perpendicular. Same thing. In other words, to say that this is an isosceles triangle. I've drawn it like an equilateral triangle because the chord happens to be same length, but it's an isosceles triangle. These two are same, and therefore from the center of the circle, the angle bisector, the median, the altitude, the perpendicular bisector, all of them are same, which is why it's both perpendicular and dividing into two equal halves. Okay, so that's a basic property all of you know. Now, if I have sorry, how do I get rid of this?
Which
Control.
will they be equal? Like in the bisecting, like will it be bisecting the perpendicular from the center? Will it bisect the chord?
Correct, it'll bisect the chord.
So
So
they're equal, right? I thought you drew 3 lines. So I thought like you're saying that they're not equal.
no, they are equal. I don't know what I said. Did I say something wrong? Okay, so
No, you didn't say anything. My bad. Sorry.
oh, okay, right. Just to be clear, the base gets bisected. When you draw a perpendicular, the base gets bisected. Very simple. Yeah. Okay. Now the more important property is if I have, right? If I have two points on the circle somewhere, let's say A and B, right? If I touch the circle somewhere and come, right? No matter where I touch and come, if I go here and come, or if I go here and then come back here, right? All of these angles same. So which angles? So this angle, let's say it's theta, okay? And this angle, let's say, will also be theta. So with a given chord AB, right? Or actually this is arc AB, doesn't matter, given 2 points on the circumference of the circle, if I touch the periphery anywhere and come back, the angle will be theta. And the angle at the center will be double, right? So let's say this is the center. If I draw a point to the center of the circle and come back to B, this angle will be 2 theta. So angle at the center will be double of angle at the periphery. Okay, that's important. The other important property that you guys should know is if I have a circle, if I have a tangent here somewhere, I have a tangent here, and if I have some chord, right? So some chord here in the circle, right? Then the angle that the chord will subtend at the periphery of the circle, which means this angle will match the angle that the tangent makes with the chord. Okay, so this is called the alternate segment theorem. I'll repeat again. So AB is the chord, and then I have a tangent which is AT. Then the angle between the chord AB and the tangent AT will be same as the angle subtended by AB on the periphery of the circle, right? So let's say this is AC, right? And obviously each of them will be half of the angle at the center. So I didn't draw the angle at the center. Let's say the center is here somewhere, right? So this angle will be 2 theta as we showed earlier. So this is 2 theta, right? That's same as before, nothing changes. Because ACB is theta, this thing AOB will be 2 theta. Okay, so as a result of that, suppose I have a semicircle. So angle in a semicircle is 90. What do I mean by that? So if I have a semicircle, let's say this is the semicircle. Let's say, so these are the 2 endpoints of the semicircle. Then if I touch this from here, if I go anywhere here, and then come back here, this angle will be 90 using the theta and 2 theta wala funda, right? So how am I using this funda? This is 180. So this is AB. AB is also a chord, and therefore this angle will be half of, right, AB. So half of 180, which is 90. Okay, and then the other thing is with chords, intersecting chords is an interesting property. So if I have a circle, if I have two chords which are
Can
intersecting.
you repeat how you got the 90?
Okay, it's exactly same as the 2 theta property. So AB is a chord. The angle that AB subtends at the center of the circle, in this case, happens to be 180 degree, correct?
Yeah.
And therefore, angle subtended at the periphery will be half of 180.
Okay.
Which is why it's called angle in a semicircle is 90. Right? If I have a semicircle, if I touch it anywhere and come back, it'll be 90. Okay, now intersecting chords is an interesting problem. So if I have two chords, like let's say this one chord here, and let's say another chord like this, right? Okay, so let's label them.
Wait,
Let's
so
call.
that means like AB has to be the diameter, right?
Yeah. If it's that's what I said. Angle in a semicircle. AB, only if AB is a diameter, it's a semicircle, right?
Okay, yeah.
Yeah, and which passes through O, which is the center. Yes. So if AB is the diameter, which means you have two semicircles, angle in any semicircle is 90. Okay, now back to this bottom diagram. I have two chords AB and CD intersecting each other at some point P. Okay, then the property that we have is AP into PB is same as CP into PD. Okay, that's a very important property. AP into PB is CP into PD. And what's interesting is this is true even if the intersection happens outside. So what do I mean by that? So suppose I have the same diagram but slightly different. So let's say I have the chord AB is like this. And chord CD is like this. Okay, so obviously they are not meeting right now, right? But if I extend them, they will, right? Sorry, I'll redraw them. Okay, so this is the first chord, and let's say this is the second chord. Okay, so right now they are not meeting, and therefore I have to extend them. So I'll extend them like this, right? And then here also I'll extend it further. Okay, so now if I label my points, okay, so if I label my chord as same thing, let's say this is AB and this is my CD. The intersection point is my P, right? It's still AP into PB, right? AP into PB is CP into PD, right? It's tempting to write PA into AP. No, you have to go from B till the meeting point, and from there you have to come to A, right? Or PB into AP, or AP into PB, whatever way, and CP into PD. So you have to go to the meeting point, and then from there go to the other end of the chord, right? And in the extreme case, in the same diagram, suppose I'm able to draw a tangent here, right? So in fact, I won't draw a tangent. I will draw something that's very close to a tangent. So let's say this line, again, the meeting point is at P, but it intersects at 2 points which are very, very close, right? So let's assume it's intersecting at 2. How do I draw this? No. Okay, for now, just go with this diagram. So let's say this is T1 and this is T2, right? Right now, T1 and T2 are different, but you can bring them close to each other. At some point, they will collide to one point, which is the tangent. So it will become T1P times PT2. So this will be same as T1P times PT2, which will be same as TP into PT, which is PT square. So the square of the tangent is AP into PB, right? If I have a tangent in the extreme case where T1 and T2 collide to one point T, then PT square is AP into PB. Does it make sense, guys? Shivank, you're okay on this one? Okay, I think those are the main properties I wanted to cover in circles. Let's stop for here today. Okay, we'll continue next week. I'll want to finish maybe another session or two, then we'll cover all the basics. Then we'll do topical questions for AMC10. Okay, chalo, bye. See you tomorrow. See you next week. Sorry.
Amazing.
Bye.